In the previous two videos, we've seen that by using the natural log, we can see that when you differentiate this, it will give you this. Even in the case of the index here being a complicated irrational number, you see by you using the natural log, you can see that this when you differentiate this, it will give you this. It will still work. Now, so when you have, let's say, when you have y equals x to the power of n. So in the previous two videos, we used the natural log to show that when you differentiate this, this gets moved down to here, and this gets minus by 1. Now in this video, well, whenever you have one thing to a power of another thing, you can use the natural log, and you can also think of e. Okay, so in this video, we're going to show that this here to be true, even when this here is a complicated irrational number. So when you have this here, think about the natural log, and then think about the e. So now we're going to use this method to show that this is, when you differentiate it, it will give you this. Okay, so start out with y. Well, normally when you prove this, normally you would use y equals x to the power of n. But I'm gonna put minus pi into here. So just so that you can see the movement of a complicated irrational number. Okay, so what we could use x to the power of pi, but let's make it even more complicated, just so that you can see what's going on. So start out with y equals x to the power of minus something complicated, a complicated irrational number. Okay, so normally we would natural log both sides, but here we're going to use a different method. We're going to use e. Okay, so starting out with this, your eye should zoom into this x here. Now rewrite this x as e natural log of x, because remember we would start out with our function here, e to the x, and then we would create an inverse version of our function, which is natural log. And then if you put, let's say, if you put x into this machine, and then you would get something, I don't know, let's say put whatever here, and then if you get this whatever and put it into here, then you're going to get back out x. So my point is that x here is the same as this thing here. So let's put this thing here into the x. This thing here is just another way of writing x. Okay, because, well, this is an inverse of this, and this is an inverse of this. So when you put this, well, this bit here is just another way of writing x. So hang on. So to do this here, your eyes should zoom into the x here, and then rewrite the x as e to the natural log of x here. Okay, so put this into here, so that will then give you this. Okay, so whenever you have something x to the power of a and then to the power of b, it's simply a times b. So don't forget, this is like one thing, this is another thing. So it's basically this times this. So you've got pi times this. Okay, and then hang on, and then now use implicit differentiation. So differentiate this. Okay, so when you differentiate this, implicit differentiation here, remember y is a function of x. So when you differentiate this here, differentiate y, that will be 1. But then because y is a function of x, you've got to times it by dy by dx. So here 1 times dy by dx, it's just simply dy by dx. Okay, so given this here, differentiate this side, that will give you dy by dx. Now you've got to imagine this as being a bubble here. Okay, so if I were to give you this, how would you differentiate this? You would, well, when you differentiate this, it would just simply be this. Okay, so or another way of thinking about it is to say that, let's say w equals minus pi l natural log of x here. So another way of thinking about this is that you've got this thing here, differentiate it, it will give you itself, but then because w is a function of x, you've got to times by dw by dx. Okay, so my point is that when you're here, imagine it as this. Imagine it as this. So differentiate this. That would just be itself. And then you've got to times the derivative of the bubble, which is minus pi times this thing here. Okay, so that would then lead you to this. Well, so at the moment you've got this times this, so this gets multiplied to the top. That would then give you this. And don't forget, because don't forget this bit here is just x to the power of minus pi. Because hang on, whenever we use this process, don't forget we are here. Okay, whenever we use this process, look at this. We started out with this. And then our eyes would zoom into this bit here. That's e to that's this thing here. And then so basically we would write x as this thing here. So hang on. So that would then take us to this. But then from here that would then take us to this. My point here is that if you have this, well, my point is that this thing here is this thing here. And this thing here is this thing here. Hang on, let me just repeat that. This thing here is this thing here. Okay? And this thing here is this thing here. So my point is that when you are here, when you get to this stage here, well, this thing here is exactly the same as this. You see, this thing here is exactly the same as this thing here. And this thing here is exactly the same as this thing here. So hang on. So when you get to this stage here, you should notice that this thing here, well, it's not actually that easy to notice, but whenever you use this process, this thing here is the original thing, which is x to the power of minus pi. So whenever you use this process, just remember this here. You're going to get you're going to get x. You're going to get x to the power of minus pi. This was our original thing. Okay, so when you get to this stage, just notice that this thing here was our original thing. Okay, so now well, when you get to this stage, realize that this was our original thing here, which was x to the power of minus pi. So x to the power of minus pi, put it into here. That will then give you this times this. Okay, so this here gets multiplied to the top. Okay, and remember that this here is an index. Okay, this here is not an index. So when you multiply it, this thing here is the normal pi, but then this minus pi here is to the power. Okay, well, anyway, this whole thing here becomes this, and then now you can see that, well, imagine this as to be to the power of minus 1. So simply this take away 1. That's why, well, you can see it here. Okay.